Yesterday, we learned that RAG starts by finding the most relevant text for your question. But that raises a tricky question. How does a computer know which paragraph is relevant when you might ask using totally different words than the document uses? The answer is a tool we met back in the foundations, embeddings. Today, we revisit them, this time as the engine that powers retrieval. Welcome back to AI in 5. Quick refresher. An embedding turns a piece of text into a list of numbers that captures its meaning. Not the letters, not the exact words, the meaning. We call that list a vector. So a sentence about a dog running in a park becomes a specific string of numbers, and any sentence with a similar meaning becomes a similar string of numbers. Meaning converted into math. The mechanic is simple. You feed a chunk of text into an embedding model, and out comes its vector. You can picture that vector as a point sitting in a giant space of meaning. Texts about similar topics land in the same neighborhood. Texts about unrelated topics land far away. So a whole pile of documents becomes a cloud of points, neatly arranged by what they're actually about. Here's why this is so powerful for search. Look at these 3 phrases. How do I reset my password? I forgot my login. I can't sign into my account. They barely share any words, but they clearly mean the same thing, and embeddings know it, because all 3 land right next to each other in meaning space. A keyword search would treat them as different. Embeddings treat them as siblings. And this is exactly where old-school keyword search falls down. It hunts for the literal words you typed. So if your document says vehicle, but you search car, it whiffs. Embedding-based search matches on meaning, so car, automobile, and vehicle all connect. For RAG, that's the difference between retrieving the perfect paragraph and retrieving nothing useful at all. So here's how retrieval really works, step by step. Ahead of time, you embed every chunk of your documents and store those vectors. Then, when a user asks something, you embed their question into a vector too. Now both the question and the documents live in the same meaning space, and you simply find the document vectors sitting closest to the question vector. Those closest ones are your most relevant passages. That's the whole trick, and it deserves a name. Semantic search. Searching by meaning instead of by exact words. It's why a good RAG system can answer a casually worded question using a formally written manual, even when they share almost no vocabulary. The system isn't matching text. It's matching intent. And here's why this step matters so much. The quality of your embeddings sets the ceiling for your whole RAG system. If the retriever pulls the right passages, the model gives a great answer. If it pulls junk, even the smartest model will produce a confident, well-written, completely useless response. Garbage retrieved, garbage generated. Get this part right, and everything downstream gets easier. So embeddings are the quiet backbone of retrieval. They turn the fuzzy, human idea of relevance into something a computer can compute in milliseconds, even across millions of documents. You almost never see them directly, but every time a RAG system seems to just understand your question, embeddings are doing the heavy lifting underneath. So embeddings convert text into vectors, points in a space of meaning, and that's what makes search by meaning possible. We've used this word vector a lot now, kind of hand-wavy. Tomorrow, we zoom all the way in and answer it properly. What exactly is a vector, and how does a sentence become a point in space? See you tomorrow on AI in 5.